Another short video today with no visuals and one on 3 different ways to look at social phenomenon, particularly with regards to probability. First of all, we have basic probability. An event like a theft or the purchase of a certain good has a particular probability of occurring in a society, like a coin flip. A fair coin will have a 50-50 chance of producing heads or tails on a flip, and the more coins you flip, the closer you will get to that 50-50 number. Now, you'll cross that probability a number of times, but will eventually deviate as more flips are performed from that objective statistic. As you throw one more heads, then you have tails. As more coin flips are performed, each coin flip matters less. One of 20 coin flips or purchases of fish is less statistically significant than one of 5. Since this is the case, you will reach a true demonstration of the 50-50 probabilities of a coin flip at infinity throws. This isn't really applicable to society though, as density of people in a city increases, for example, so too does the probability of a crime or the purchase of things like fast food. The proverbial coin is ever-changing and doesn't have an inherent probability. So we need a better way to look at society. That's where social collision theory comes in. Social collision theory is an approach that sees us look at social probability the same as chemical probability. An event like the collision of particles is made more or less probable by things like pressure, temperature, or volume. In the case of social phenomenon, we look at things like population density and economic stability. Specifically with population density, we can see how this deviates from the prior model, since here, more coin flips means more probability of landing heads, so at infinity, a fair coin that functioned under this model will not demonstrate a 50-50 probability. Now we can move on from basic frameworks of analysis and move on to what evidence is valid for analysis with the famous Raven's paradox. Now this, strictly speaking, isn't a paradox, but let's push past that for now. The Raven's paradox is also kinda wordy, so I'm gonna try my best to explain it. If we look at a claim about ravens, that all ravens are black, we can also then say that all non-black things aren't ravens. So far so good. These statements are ostensibly saying the same thing, that all ravens are black, and any instance of a non-black thing isn't a raven. The problem here comes when you try to evidence this second statement. We end up doing ornithology while never looking at a single bird. We find the evidence that X is both non-black and not a raven, and we take it as supporting evidence for the claim, which amounts to all ravens are black. Why this isn't really a paradox is the part that statistical significance plays in this problem. It isn't a paradox because of all the non-black things that exist. A single thing like a chair isn't statistically significant. It's negligible when evidencing that claim. Now, where these 3 principles come into play in society is when we look at a social phenomenon in this way. When we look at evidence given for claims in any group of people, we find that it often fails at grasping these basic principles. We can look at how people perceive immigrant populations, for example, and find that people with more consistent exposure to that population have a more positive view on it. That can be because without the exposure, individuals can very easily fall into the Raven's paradox, and at that point, a claim like immigrants are more likely to be criminals is evidenced by any non-immigrant not being a criminal. In that same vein, people may also argue that immigrant populations are more likely to be criminals, while dismissing all the things that make the event of a crime more probable.